Niacin, also known as vitamin B3, is a quiet powerhouse in the world of nutrition, a nutrient that plays a central role in the body's ability to transform food into energy. While it may not be as widely discussed as vitamin C or iron, niacin is absolutely essential for carbohydrate metabolism, especially in the critical phase of converting glucose, the simple sugar derived from starches, into ADP, the molecule that acts as the body's universal energy currency. Without sufficient niacin, the body's finely tuned energy machinery begins to falter, resulting in sluggishness, fatigue, and metabolic inefficiency. But when present in optimal amounts, niacin unlocks one of the most important processes in human physiology, the clean, steady generation of energy from food. At the core of niacin's function is its role in creating two critical coenzymes, NAD, nicotinamide adenine dinucleotide, and NADP, its phosphorylated form. These coenzymes are required in hundreds of metabolic reactions throughout the body, but their most vital function lies in their ability to facilitate the transfer of electrons in the production of ADP. Every time you consume a bowl of brown rice, a sweet potato, or a slice of whole grain bread, your body begins breaking down the complex carbohydrates into glucose molecules. These molecules enter the bloodstream and are delivered to cells, where the real metabolic action begins. Once inside the cell, glucose undergoes a multi-step process known as cellular respiration. The first step is glycolysis, where glucose is partially broken down into pyruvate in the cell's cytoplasm, producing a small amount of ADP. But the majority of energy is produced in the mitochondria, the cell's energy factories, through the citric acid cycle and oxidative phosphorylation. And here, niacin takes center stage. NAD and NADP act as electron carriers. They pick up electrons during the breakdown of glucose and transport them to the mitochondria, where these electrons help generate a proton gradient that powers ADP synthase, the enzyme responsible for creating ADP. Without NAD, the flow of electrons stalls and the energy production chain grinds to a halt. This makes niacin an indispensable part of energy metabolism. It doesn't just support energy production, it enables it at the most fundamental level. A deficiency in niacin leads to a breakdown in this process, which is why one of the first signs of niacin deficiency is fatigue. Over time, more serious symptoms can develop, including weakness, poor concentration, and in severe cases, a condition known as pellagra, marked by dermatitis, diarrhea, dementia, and if left untreated, death. These outcomes, though rare in modern diets with fortified foods, underscore just how essential niacin is for life itself. But niacin does more than support basic energy production. It also plays a protective role by supporting DNA repair and helping to manage oxidative stress within the cell. During energy metabolism, especially when carbohydrate intake is high, reactive oxygen species can be generated as byproducts. NADP, the niacin-derived coenzyme, is crucial in the production of reduced glutathione, one of the body's most important antioxidants. This makes niacin not only vital for producing energy, but also for ensuring that the energy-making process doesn't damage the very cells it aims to power. Fortunately, niacin is found in many wholesome, everyday foods. Whole grains like brown rice, wheat berries, and oats retain their niacin content when unrefined. Legumes such as lentils and chickpeas, as well as nuts and seeds, are also excellent sources. Animal products like chicken, tuna, and turkey are naturally rich in niacin, but in plant-based diets, whole grains and fortified foods usually provide adequate amounts. It's also important to note that the body can synthesize niacin from the amino acid tryptophan, found in protein-rich foods like eggs and dairy, another example of the body's elegant backup systems to ensure a steady supply of this essential vitamin. Thanks to fortification policies introduced in the mid-20th century, many refined grain products such as white bread and enriched cereals now contain added niacin. This has significantly reduced the incidence of pellagra and has ensured a baseline level of intake across much of the population. Still, whole foods remain the gold standard. They offer not only niacin but the full spectrum of cofactors, fiber, and antioxidants that support overall metabolic health. In every sense, niacin is a metabolic linchpin. It enables the transformation of carbohydrates into clean-burning, long-lasting energy. It supports brain function, nerve integrity, and cardiovascular health, all through its central role in energy metabolism. And when you eat foods rich in both complex carbs and niacin, you're not just nourishing yourself, you're optimizing the engine that powers your every movement, thought, and breath. So the next time you build a meal, think about more than just the calories. Think about whether that meal contains the nutrients that help those calories become something useful, whether it gives your body not just fuel, but the tools to use that fuel effectively. That's what niacin does. It doesn't just sit in your food, it sets it in motion.